So, after learning about different matrix operation, let us now discuss another very important concept called the inverse of a matrix. So, just like in mathematics, when we divide a number by another number, we actually often use its reciprocal, right? Similarly, in matrix algebra, the concept of inverse helps us reverse the effect of a matrix multiplication. So the inverse basically is a special matrix. Inverse of a matrix is basically a special matrix, which when multiplied with the original matrix gives us a identity matrix. So this idea is very helpful and helps us in solving actually systems of linear equations and in many physics and engineering related problems. Now, so in this topic, we'll learn what an inverse of a matrix is and what are the conditions for its existence. It is not that every matrix has its inverse. There are certain conditions which a matrix must satisfy in order to have an inverse. So we'll look into this topic now. So consider two matrices such that AB is equals to BA is equals to I. Okay. Now, so what does it mean? That AB is also equal to I, right? Now, let us multiply A inverse from the left hand side of this equation. So, in A inverse AB is equals to A inverse I. Now, A inverse A gives us what? I multiplied with B is equals to A inverse I. So from here what we can identify is that B is equals to nothing but A inverse, right? Now now what does B inverse signify? B inverse is nothing but A inverse and inverse of that. So what if we inverse anything twice? It gives us the original A. So B inverse is nothing but A. So B inverse is basically A and vice versa. A inverse is also equal to B, right? Now let us look into some of the properties of A inverse. Prior to that, let us now now let us look into some properties. So what are the properties of inverse of a matrix? Number 1, A inverse transpose is equals to A transpose inverse. Alright. Number 2, A inverse determinant of A inverse is equals to determinant of A and inverse of that. Alright. Property number 3, inverse of A inverse gives us A. Now A plus B inverse is equals to A inverse plus B inverse. Alright. Also A B inverse is equals to B inverse A inverse. Alright. Similarly, A B C D inverse is equals to D inverse C inverse B inverse and A inverse multiplied all together. So also another property says that if A and B are invertible, then A transpose A dagger AB BA are also invertible. Alright, so if A and B are invertible, A transpose A dagger, B transpose B dagger, AB, BA are all invertible. Now let us look into some of the formulas for finding inverse. So what is the formula for finding inverse? So A inverse exists by the formula adjoint of A by determinant of A. So what is the probability that a matrix A will have an inverse? If and only if the denominator is not 0, that is, if determinant of A is not equal to 0, only then will A have an inverse of itself, right? So non-singular matrix having a determinant of A not equals to 0 are invertible. So this is basically the condition for for finding an inverse of a matrix, that it should be non-singular. Only if it is non-singular, only then will it have its inverse. Alright. Now let us solve an example. What does the example say? It says find A inverse where A is equals to 1113. Alright. Now determinant of A is 3 minus 1 is equals to 2. So determinant of A is not equals to 0 and hence it is non-singular. And so its inverse exists. So A's inverse exists. Alright. Now what we have seen, that in order to find inverse of A, what is the formula? Adjoint of A by determinant of A, right? So adjoint of A we have found in the last video. The formula for finding adjoint of A is minus 1 to the power m in m plus n into cofactor, right? Sorry, into minor, not cofactor, and the entire thing is called the cofactor. So basically transpose of the cofactor of A gives us adjoint of A, right? Now there is a short trick to find adjoint of a 2 cross 2 matrix. Although this rule does not apply for a 3 cross 3 matrix, but then this applies for a 2 cross 2 matrix. What is the short trick? The short trick is just reverse the diagonal elements. So it is the diagonal elements for this matrix are 1 and 3. So we'll write 3 here and 1 here. So it becomes 3 1 and multiply a minus sign with the non-diagonal elements. This gives us the adjoint. Alright. Now A inverse is equal to adjoint of A by determinant of A. What is determinant of A? Determinant of A was 2. So A inverse comes out to be 1 by 2, 3 minus 1 minus 1, 1. So this is the inverse and this is our answer. This is the inverse of A. Alright.